So let us start with today's meet. Welcome for second lecture of chapter 1, Rotational Dynamics, on today, that is 24th of June. Yesterday we were talking about circular motion. Yesterday we discussed its kinematical part. Assuming the body already is executing circular motion. Today we will proceed further with its kinetics. That is dynamical part, in which we concentrate on the cause behind the motion. ये मोशन क्यों शुरू हो जाती है, ये कॉज हम लोग 1 minute I will set my setting. Hope, are you getting now my voice? Are you getting my voice now? I hope now everyone is in and can getting the point. So yesterday, by considering kinematical part of circular motion, today we'll proceed further with its dynamics, means the cause behind the circular motion. Circular motion is the motion of the object along a curved path but constant radius. In most simplest case, we consider the motion of object along the circumference of the circle. Because circle has fixed radius. So in simplest case, motion performed by particle along the circumference of the circle is the example of circular motion. In circular motion, particle has angular values as well as linear values. That is, it has angular displacement, angular velocity, and also if acceleration. Similarly, the particle also is assigned with linear displacement, linear velocity, and linear acceleration. Let us talk about linear velocity and angular velocity. What happens if the particle is performing motion in the plane parallel to earth horizon? Let us discuss about its linear velocity. Linear velocity is always tangential at a given position. So at this point, tangential to this circular path at the point. At this point, is it tangential? So every time what happens? The direction of linear velocity changes. If you talk about its angular velocity in anticlockwise sense, it is along the axis pointing up. Unless the direction changes, angular velocity does not change. So angular velocity here not changing in direction, but linear velocity continuously changes in direction. If angular velocity in magnitude also remains constant, then angular velocity in direction magnitude being constant, you can say uniform. But every time direction of linear velocity changes, if angular velocity is constant, then there is no angular acceleration. But being direction of linear velocity change, you are getting linear acceleration. So in circular motion, always linear acceleration is present in any type. In every type, this is present. We come across certain examples in which, along with change in direction, magnitude of velocity also changes. There are few circular motion in which direction changes, but magnitude remains constant. That is, speed with which particle is executing circular motion remains same. Here, if it is 5 meter per second, at this point also it will be 5 meter per second. So linear velocity changes in direction, in this case remaining constant in magnitude. In few circular motions, both simultaneously change. The acceleration, if the rotating fan with constant angular velocity is switched off, then magnitude of linear velocity gradually decreases till the fan rotation stops. 1 minute, let me check whether is there any problem. No problem at all. So no questions from your side. Everyone is getting audio, video clear. So what happens? This linear change velocity changes direction in UCM as well as non-UCM. But in non-UCM, additional to linear acceleration, one more acceleration gets added, which is called tangential acceleration. This linear acceleration is also called radial or centripetal. It is denoted by symbol AC or AR. So, radial acceleration is present in uniform circular motion, and in non-uniform circular motion, along with radial acceleration, you will get presence of one more acceleration, which is tangential acceleration. So in non-uniform circular motion, net acceleration produced is a radial and a tangential. Magnitude of net acceleration in non-uniform circular motion is then given by AR square plus AT square cos square root. So this is net acceleration present in non-uniform. While in uniform circular motion, being speed constant, net acceleration is only the radial acceleration due to change in direction of linear velocity. So remember these points well. In uniform circular motion, net acceleration is equal to radial acceleration. In non-uniform circular motion, along with radial, tangential acceleration is also there. It is due to change in magnitude of linear velocity, and net acceleration is the effect of both these. Net acceleration is given by square root AR square plus AT square, where here A net in uniform circular motion is simply equal to AR. So the acceleration is present in both the cases, only their values differ from each other. Let us talk first about linear uniform circular motion. So we are out of these two, first we'll discuss uniform circular motion. So net acceleration produced or present during this motion is of radial type. It is also called centripetal and represented by symbol AR or AC. So this acceleration is present only in uniform circular motion. So this acceleration is always directed towards the center and opposite to direction of radius vector. Radius vector is from center to circumference, while acceleration is from circumference to center and its value is, how will you find it? Linear acceleration is what we studied last year, v square upon r in magnitude or r omega square. Any form you can choose. And in vector notation, you will write a bar is equal to v square upon r. Minus sign with respect to position vector, and this will be r bar. So a bar is equal to minus v square by r starts. This is unit vector in the direction of position vector. When position of particle changes, every time the direction of centripetal acceleration changes. So the motion is accelerated. So first characteristics of uniform circular motion, it is accelerated motion. Acceleration is observed during this motion. Second characteristics, it moves with constant speed. So time taken to complete one revolution is same. So it is also periodic. These are the characteristics of UCM. ये यूसीएम में होता है. सो दिस इज फॉर द ऑब्जर्वर ऑब्जर्विंग दिस मोशन. जो ऑब्जर्व कर रहे हैं मोशन, उसको लगता है कि ये पार्टिकल को सेंटर टुवर्ड सेंटर सीकिंग एक्सीलरेशन है. बट इफ यू कंसिडर द पॉइंट ऑफ व्यू ऑफ पार्टिकल itself, the object performing circular motion, it never experiences such acceleration, and acceleration is only produced if force acts on it. So acceleration is there means what? Indirectly we can say some centripetal force is acting on this particle, and magnitude of this centripetal force we can find with basic formula m into a, that is a v square divided by r. Direction of force is in the direction of acceleration. जो डायरेक्शन में फोर्स लगता है वही डायरेक्शन में एक्सीलरेशन प्रोड्यूस होगा. सो सेंट्रीपेटल फोर्स इज आल्सो अलोंग द रेडियस and seeking towards center. So magnitude of centripetal force will be mv square by r. तो हम लोगों को क्या लगता है, जो मोशन देख रहे हैं उनको लगता है कि दिस पार्टिकल इज acted upon by this centripetal force. ऐसा हम लोगों को लगता है. But if you consider the view from particle point, then this particle never experiences such force. Instead, it experiences outward force. For example, एक बस है, व्हीकल है, वो टर्न ले रहा है, उसमें सपोज लेफ्ट साइड में पैसेंजर्स बैठा है, तो पैसेंजर को लगता है when bus takes left turn, he is being pushed away, he is pushed off towards the right. तो इसको क्या लगता है पार्टिकल को कि मेरे ऊपर सेंट्रीपेटल फोर्स नहीं एक्ट हो रहा है, इंस्टेड आई एम बीइंग पुश्ड अवे फ्रॉम द सेंटर. ये तो हम लोगों को भी एक्सपीरियंस हो जाता है बहुत बार. तो ये कंसेप्ट भी हम लोगों को एक्सप्लेन करनी पड़ेगी. एंड दिस इज ओनली ड्यू टू एक्सीलरेटेड फ्रेम ऑफ रेफरेंस. बस ऑलरेडी मोशन में है तो उसको खुद का एक्सीलरेशन है, उसमें पैसेंजर बैठा है, तो पैसेंजर इज already situated in accelerated frame of reference. So for the passenger or the object which is already in accelerated frame of reference, instead of centripetal force, it experiences outward force. But this outward force जो है वो हम लोगों को दिखता नहीं है, वो पैसेंजर को फील होता है. ऑब्जर्वर जो बाहर से ऑब्जर्व कर रहा है, he never have experience of this force experienced by the object outwards. But that passenger is experiencing that force, and hence we have to assume one more force, which is centrifugal. So to explain this behavior in accelerated frame of reference, we have to assume the existence of one more force, which is a centrifugal. It is totally pseudo. It is experienced by the object performing UCM, not experienced by the observer observing that particular motion. So centrifugal is totally pseudo. Only to explain this, we are considering the centrifugal force, and this centrifugal force is equal in magnitude, lies in the same direction, only in opposite. So if this is centripetal, this will be centrifugal outward force. So this we have to assume present in addition to centripetal force. So this is the concept of centrifugal. So remember well, circular motion, two types, UCM, non-UCM. In both types, linear acceleration is always present. Only in UCM, linear acceleration is AR, while in non-UCM, linear acceleration is AR square plus AT square root. Here AT term comes due to change in magnitude of linear velocity. So both cases linear acceleration is present, only their magnitudes are different. Being accelerated, some force should act centripetal, and to compensate you have to assume centrifugal. So centrifugal is not a real force. We are only assuming it. So this is the basic concept behind circular motion. So we first will consider applications of UCM. We already have stated UCM. We'll